How much carbon dioxide are we currently putting into the atmosphere?
This plot shows the amount of carbon held in the deep ocean, its upper layers, the soil, the atmosphere, and in plants in gigatons of carbon. Shown in red is the annual increase. The conversion between gigatons or billions of tons of carbon to parts per million of carbon dioxide in the atmosphere, which is often quoted, is 1 part per million of atmospheric carbon dioxide is equivalent to a bit more than 2 gigatons of carbon, and that is 8 gigatons of atmospheric carbon dioxide, or 17 gigatons of total carbon dioxide emissions. Carbon dioxide in the air is increasing at the rate of 2 to 3 parts per million per year. This has been happening for decades. While historically it has been within the range 180 to 280 parts per million, it is now comfortably beyond 400 parts per million and increasing. The deep ocean holds more than 10 times the carbon in the biosphere, but the exchange of carbon between the biosphere and the deep ocean is very slow. Most of the excess carbon dioxide and heat stays in the biosphere and builds up, and the earth warms. Even if we were to stop our emissions now, the excess CO2 will keep warming the earth. At current emission rates, the temperature would rise by about 2 degrees centigrade by 2036, and that is a dangerous level beyond which many processes become irreversible. The Arctic is warming at twice the average rate. The melting of Arctic ice and glaciers will decrease Earth's reflectivity, allowing more heat to reach the oceans and get absorbed, cause permafrost melting and forest dieback in high latitudes, affect ocean circulation, making warm regions hotter, and causing forest dieback in the tropics as well. The biosphere will be a less effective carbon sink, and still more carbon dioxide will accumulate in the atmosphere. These are things that we have discussed. Globally, economic and population growth are drivers of increases in carbon dioxide emissions. Currently, we consume 15 terawatts of power. That's 10 to the power 12 watts. Our carbon intensity, that is the amount of carbon used per unit of energy produced, has been going down. The reason is that coal, which is basically pure carbon, was the dominant fuel a century ago. But over time, oil, which has an intermediate carbon content with roughly a CH2 structure, and natural gas, which has a lower carbon content with a CH4 structure, have become important sources of energy. When hydrocarbons burn, the carbon in them turns into carbon dioxide and the H in them turns into water vapor. It turns out that the bonds of a carbon dioxide molecule are very strong, so a lot of energy is liberated when it is formed, about 4 times as much as from the formation of water vapor. So each carbon atom in fuel gives about 4 times more energy than each hydrogen atom. Therefore, the total energy released from the burning of coal is half the total energy released from the burning of natural gas, with oil in between these, for the same amount of carbon dioxide produced. To reduce carbon intensities further below that of natural gas, we would need to switch to non-fossil fuels. Even though we are planning to do this, to produce some energy by other means, our total energy consumption continues to rise, and so our burning of fossil fuels isn't reducing, but is actually still rising. We need to turn these curves around and take them down to zero pretty fast. This is a big task. Shown here is the average carbon dioxide emission rate, yearly and per person, over a 100-year period. 36 gigatons of carbon dioxide are emitted yearly. An average European emits 11 tons of carbon dioxide per year. We have discussed the effects of all of this excess carbon dioxide. Climate change takes time. Perhaps that is why we become immune to it and psychologically immune to hearing about its dangers. But the change is not quickly reversed. Especially after a point, the changes can become irreversible and abrupt. It is hugely advantageous to err on the side of caution. Given the risks, we should be proactive rather than reactive.